This is 6th grade math 8.2. Rates is the name of the lesson. I'm on page 407. So if you guys would open up your books to page 407. Oh, I was on the wrong. 407. So here we go. Rate. A rate is a ratio with two measures that have different units. And I'm getting it right from the book. If you can't read my writing, it's right, almost right next to the word, the vocabulary words. Okay, so an example of a rate, the one they use in the book is 15 miles in 3 seconds. So that's a ratio. There's your fraction number on the top. They have different measurements. One is in miles, one is in seconds. Okay, a unit rate is a rate with a denominator equal to 1. So let's take a look at the one I have up here. This is not a unit rate because this bottom number is not a 1. Well, to make 3 a 1, you would divide it by 3. And then we still, since it's a fraction, we still, if we divide the bottom by 3, we divide the top by 3. So that's the same as saying you're going 5 miles in 1 second. Okay? And we'll talk about unit rates. If you go to Walmart or you go to Sam's, they will have on the tags next to the things you're going to buy, the price tags, it will say the unit rate. Like for example, if it's cereal, it'll tell you how much it costs per ounce. If it is, if you buy like a case of pop, it'll tell you how much it is per can. I don't know, if you buy diapers, how much it is per diaper, whatever it might be. Those are the unit rates, and I use that to compare prices, whether you should buy the big, the big pack of something or a smaller pack of something. So let's take a look at these and see what these look like. The International Space Station orbits Earth at an average rate of 15 miles every 3 seconds. How long will it take the space station to travel 150 miles? Well, the first thing you do is you write the rate that you know. The rate we know is it goes 15 miles in 3 seconds. When will it equal 150 miles? Now notice when I write this, I have the miles both on top, and then this is like an unknown. It's missing. And if you notice, this is exactly like what we were doing in last lessons when you were filling the missing part in the equivalent ratios. So you do the same thing. I look at this and say, what do I do to 15 to get 150? I times it by 10. So what do you do to 3? Since you do the same thing to the top and the bottom, then it would take 30 seconds to go 150 miles. So basically you're just writing out two rates, you're missing one thing, and you're putting the numbers into the correct places. And this, they're explaining they're doing the same thing I just did. Okay? It says write the space station's average rate of 15 miles in 3 seconds as a unit rate. Now I kind of did this in the beginning. A unit rate, 15 miles in 3 seconds. The unit rate means this bottom number right here has got to be 1. So we're going to divide this by 3 to make it be 1 second. So we also divide this by 3, so it goes 5 miles in 1 second. Did I do that right back there in the, sorry, I'm going back to, yeah, I did. Okay, so that's our unit rate. So you got to be really careful when it says to use the unit rate to get a 1 down at the bottom. So this is copy and complete the statement. It's just the missing, same thing we're doing. We're just putting real life, labels on it basically. What do you do to 5 to get 20? 5 times 4. So what are we going to do to 10 to get the missing part? Times it by 4. So in other words, if 5 pounds cost you $10, 20 pounds will cost you $40 at that same rate. This one, that's supposed to be missing. You're supposed to not know that one. Pretend like it's not there. So to get from 6 to 12, you would times by 2. So 35 times 2 would be 70. So it's supposed to be 70 miles. It gave us the answer. Give us the answer on all of them. This, you're not supposed to know this one. That's not supposed to be there. So this must be this is going to a unit rate, see, because this is going from 8 to $1. So we divide by 8, divide by 8. So 4 ounces would cost us $1. Okay, so we can use this in measurements also. There are 2 and 5400 centimeters in 1 inch. So right away you can write that as a ratio. 2.54 centimeters in 1 inch. How many centimeters are in 3 inches? Well, we would put inches across from inches because those we have to be consistent, and then the how many, that would be the unknown. And actually we would start, let's do some algebra, we would put an x there. So what would we do to 1 to get 3? We would times it by 3. What do you do to the 2.58? Times it by 3. So what's I just said 8, it's not 8. 2.54 times 3, 12, carry the 1, 16, carry the 1, 7. It would be 7.62 centimeters. Okay, so they're showing that they're multiplied by 3 just like we did. Use the ruler to check. 3 inches is about 7.6 centimeters, so our answer is reasonable. Example number 4, comparing unit rates. And this is where I was saying I use this in the store to compare how much things cost. A 12-ounce tub of popcorn cost $3. A 20-ounce tub of popcorn cost $4. Which tub is the better buy? So if you look at this one, let's put the money on top. $3 for 12 ounces. Over here, $4 for 20 ounces. So the first thing I can see in these fractions is each of these can be reduced. If I divide by 3 up here, and divide by 3, $1 here would equal 4 ounces. So that's $1 for 4 ounces. I could divide this by 4 and this by 4, so $1 here would be equal to, get you 5 ounces. So which is the better buy? The big one, the 20-ounce one, will get you more for your money. 5 ounces for every dollar, and this one's only 4 ounces for each dollar. The unit rates again. And they're doing it, is that the same? We got the unit rate to $1, they got the ounces. They did it per ounce, we did it for each dollar. It doesn't matter, they will come out the same. Okay, so the 12-ounce tub costs more per ounce, so the 20-ounce tub is the better buy. That's what we came up with. How many centimeters are in 2.5 inches? Well, in order to do this one, we need to know how many centimeters are in 1 inch, and that was given to us in the last one. There's 2.5 centimeters in 1 inch. How many would be in 2.5 inches? That would be our question mark. So what would we do to 1 to get 2.5? We would take it times 2.5. So we take this times 2.5. So you think you're going to get away from that multiplying, but it doesn't happen. So here I'm multiplying with my decimals. Remember, I don't have to line them up, pretend like they're not there till the end. Placeholder 8, 0, carry the 1, that would be 5. It's going to be a 3, 6, put in 3 places. 6.35 centimeters is in 2.5 inches. There we go. Ooh, let me erase here, sorry. Okay, what if? In example 4, suppose a 16-ounce tub of popcorn costs $3.68. Is the 12-ounce tub or the 16-ounce tub a better buy? Well, if we go back to the 12-ounce tub, it was, in our work, the 12-ounce was $1 for 4 ounces. So let's see what this one comes out to be. $3.68 for 16 ounces. So if I divide by 368, that's going to get me my dollar. Divide by 368. 16 divided by 3.68, that's not the best, funnest dividing to do. $368. All we have to do is get that first number. Let's try it times 4. And 368 times 5, that's going to be too many. So that's 4 point something, but it's going to be bigger because we didn't use all the numbers, so it's going to be just a little bit more. So it's just a little bit better deal. It's only 23 cents per ounce, so we're getting just a little more than 4 ounces. So the 16-ounce tub is a better buy. Okay, example 5, excuse me. A driver completes 5 laps of a race in 3 minutes and 30 seconds and continues driving at this rate. How many laps will the driver complete in 10.5 minutes? Now, I think we talked a little bit about these. One thing is to set up, let's set up the ratios. We know they can go 5 laps in 3 minutes. Excuse me, 3 minutes and 30 seconds. How many laps will they complete in 10.5 minutes? That's 10 minutes and 30 seconds. Five laps, 6. What are we going to do? That's 5 laps of a race in 3 minutes. How many laps would they complete? So we can just keep adding. If they keep going, the next round, if we times this by 2, that'll be 6. That'll be at 7 minutes. They will have gone 10 laps. Because if they did 5 laps in 3 minutes 30 seconds, we just take them times 2 for another time. That'd be 10 laps in 7 minutes, and basically, or else you can just, instead of timesing by 2, just add this to it each time, these numbers. So if 15 laps would be 10 minutes 30 seconds. So it's got to be C. Let's see how they did it. Oh, they changed the minutes and seconds. That's good. Probably a good plan. 3.5 minutes times 2 times 3, yep, 15. Almost used common sense on that one. In example 5, they completed 5 laps in 5.5 minutes. How much would the driver complete in 22 minutes? So 5 laps in 22 minutes. So they do 10 laps. Oh, no, wait. Sorry. It's not 22 minutes. I have the wrong thing here. They did 5 laps in 5.5 minutes. So we can do like them. Let's go ahead and just make a table. We got to get up to 22 minutes. So let's double it. 10 laps. 5.5 and 5.5 is 11. Then they do 15 laps. I keep adding 5. It'd be 16.5 minutes. So this time I'm adding 5. This one I'm adding 5.5. Add this time. So 20 laps, 16.5 plus 5.5. There's my 22. So they would do 20 laps, just using my table. Okay, so that's it. Okay, so you're finding, basically we have rates and we have unit rates. Just remember, a unit rate, you need to get the bottom of the fraction to be equal to 1. And that's it. We'll see you next time.